Hi and welcome back to another LeetCode video. Today we're looking at another problem from the LeetCode 150 list from the math and geometry section. And this problem is a medium one. It's LeetCode 43 multiply strings. And we're given two non-negative integers nums1 and nums2 represented as strings. We should return the product of num1 and num2 also represented as string. Note, you must not use any built-in big integer library or convert inputs to integer directly. So, right. So here's an example, obviously with strings, kind of pointless to do the calculation, I guess, or maybe we should do it, but yeah, we should actually do it. Well, what is notable is that both numbers are going to be larger or equal to 1, and they will only consist digits, and they don't have any leading zeros except when there are zeros. So let's go to the drawing board and put this in here. Right. So in order to solve this problem, I suppose we should remind ourselves on how to do integer multiplication by hand. Right. So how would you how would you do this, right? How would you multiply these two numbers together? Well, you would do with you would basically calculate 456 times 3, right? And then you would add 456 times 20, and you would add 456 times 100. That's basically what you would do, and you would add all of them up. Now, you can simplify this a little bit. You could just say, okay, I'm not going to use zeros here. I'm going to add them here right away. Just a shift to the left. And now, suddenly, we have our digits from 1 to 3 written like so. So I'm thinking about breaking up this multiplication into single digit by number multiplication. And multiplying a number with a digit is kind of relatively easy, right? It's more straightforward. And then we just need to iterate over all of the digits in the number 1, 2, 3 from the back. And just, you know, we compute the result of 2 times 456, and then we just multiply it by 10. And here we multiply it by 20. So now how does this multiplication 4, 5, 6 times 3 look like? Well, very simple. So we calculate first. What do we do? So the first thing we do is we calculate 6 times 3, which is 18, right? We have 8 and a carry of 1. Now we compute 3 times 5, which is 15. Add the carry, so it becomes 16. You have a carry of 1. Now we do 3 times 4, which is 12. And we have a carry. And that is now our value. So that is the result of this. I think we should put this mechanic into a little helper function, and this mechanic into a little loop that just uses the helper function. And I think that would make it quite easy for us to implement the solution where we really only look at individual digits and don't compute it directly, as I said in the problem, where we convert the inputs to integer directly. So we only convert, I suppose, the digits, but not the whole numbers. So yeah, well, you know, we're going to have a result variable, right? And maybe we should assume it's 0. And we're going to have to return the string value of it. I'm going to store it as a decimal value while we do the addition. I mean, you could go overboard and say, okay, I want to do string addition. But I don't want to do that. So we're going to iterate over all of the digits in nums1. That's our first number. And then we're also always going to right shift our result by 10. Then we're just going to add the integer. Well, we need a little multiply helper, right? Multiply helper. And we pass in our digit string and our num 2. Already seeing the first typo here. Right, and this shift by 10, switching back here, is doing this. So in the first step, we start with the result value of 0, multiply by 10, nothing happens. Then we compute the result of the first digit. I suppose we're doing it from the backside. So 1 times 256, and then in the next iteration of our little for loop, we multiply it by 10, so it gets right shifted. Then we add 2 by 256 to our result, and again, sorry, left shifted again. So that's how we build up the result. And now we just need a little helper function, and it takes a digit, and it's going to take a number. Both of them are going to be string, just to make sure that is illustrated here. And it should return, going to return, because like I said, we don't want to do integer addition, string addition. Right, so so the product, we're going to start out with a 0, and we're going to return it then at the end. And what do we do in between? Well, we need to iterate over all of the digits in num. In num2. In num. Right. Well, our product, we're going to do the right shift thing again. We're going to multiply it by 10 to do the left shift. And then we're going to add to our product plus equals, well, the integer value of the current digit multiplied with the multiplication digit that we need. Now you can see that we iterate from left to right now, but that's not an issue when we do that. We're basically going from this direction, and we're just multiplying that and then shifting by 10 and add. So illustrate this. So what happens here is we do 3 times 4, which is going to be 12, right? And then the next step we compute 3 times 15. And by the way, we're adding then the 0, that's the left shift. Then we do 3 times 5, which is 15. So we're adding 15. And now you can already see, so this is 135. Then we do another left shift, and we compute 3 times 18. So we add 18 to this. And what we get is then 3, 5, 8, which is exactly this. So whether you start from the back or from the beginning doesn't really matter. Cool. So yeah, that's all that. That's everything that is there to do. Let's just run through the test to make sure that it takes anywhere. Nums1 is not defined, right? Because it's called a num. And similarly, we're also iterating through the digits from the front here with nums1. Not only. Cool. So the test cases pass. Submitted to make sure all of them pass. Then we can talk about the pass. And now let's talk about the space and time complexity. Well, so we have a loop over all of the digits of nums1. And how many digits are in nums1? Well, log nums1 many digits are. Or, well, we could say, let's say n, press that like so. So n is length of num1, which is the number of digits, and m is length of num2, m. So our loop down here is actually O of n. But what is the loop in here? Well, it's O of m, right? So it's O of n times m time complexity. And how much space? Well, we need to store, well, in the worst case, if you have two numbers, let's say 10 times 10, that will be 100. If you have 100 times 100, well, you get 10,000. So roughly, you get n plus m space. And that, I think, is everything you need to solve this problem.